So in this video, this is the second part of looking at volume of 3D shapes. The previous video we looked at the formulas, and in this video we'll be looking at various examples of various volume questions relating to spheres, cones, pyramids and frustums. So let's start off with some basic examples. So in these questions, what we're asked to do is, for question 1, we're asked to find the volume to 2 decimal places. So here it's been specified on that we're wanting to we need to round our answers up to 2 decimal places. So let's get started. So for the first one, we've got a sphere. Now obviously what's important is you have the formulas to hand, or that you've memorized what these formulas are. So these are the general formulas that would be given for these particular shapes. So the first one we're looking at is for a sphere. So the first one is going to be 4 over 3 pi r cubed. So here what we're going to do is we're going to substitute. Now for this, with a sphere, the only information we've been given is that the radius is 2. So what I'm going to do is we're going to substitute 2 into this formula. So I've got v equals 4 over 3 times pi times r cubed, or 2 cubed I should say, substituting that in. And it's important that you write down the steps. So you don't necessarily need to write down the formula to get your first mark. It just needs to show evidence that you have substituted the values from the question into the formula. So I've got v equals 4 times pi times 8, and that's over 3. And then v equals, now if I then do 4 times 8, which is 32, I've got 32 over 3 pi, and that's going to be in centimetre cubed. And now this is what we call leaving your answer in terms of pi. And as you can see, I've gone nowhere near my calculator as such, but because the question's asked me to give my answer to 2 decimal places, I then need to type that into my calculator to get my answer. So let's first of all get a calculator up, like so. And what we're then going to do is type this value in. So if I wanted to, I'm going to type in the whole sort of calculation. I've got 4/3, and I've scrolled across, times pi times 2 cubed, and you can see that I've just typed in everything that's in that first line. I press equals, and it's giving me 32 over 3 pi, which is exactly what I've written. So your calculator, if it can, will always give you the exact value, and in this case it's all going to give you in terms of pi because it's obviously using pi. But if I press the SD button, it comes up with 33.51032.164. Now in an exam, what I would probably recommend that you do is, if you're not so comfortable with rounding, which really you should be at this level, but worst case scenario, just copy whatever is written on your calculator and then go on to round. So for this, I'm just going to simply save a bit of time. I'm going to round this number looking at my calculator to 2 decimal places, so it's going to give me 3351. So v equals 33.51, and then don't forget the units, which is centimetre cubed, and there is our final answer. For B, here we've got a cone. So again, for the volume of a cone, it's going to be 1/3, and then it's the base of the cone, which is pi r squared, and that's going to be multiplied by h. Now the brackets, again, as you can see in the formula, there is no brackets for the pi r squared, but basically when you're working out the volume of a pyramid or a cone, what you want to do, it's always 1/3 times whatever shape the base is times the height. And that's always a way that I always remember what the formulas are. So again, I'm going to substitute the numbers. So here h is equals 24, and I then need to work out the base. Now to work out the base, which is a circle, I need to know what the radius is. Now in this question it's giving me the diameter, so the diameter is 20, so therefore the radius is going to be 10, and it's the radius is what I need to use. So for this I'm going to do 1/3 times pi times 10 squared times 24, and v equals, so again, if I wanted to, I could write that as 100, and then that will become 2400. So all I'm going to do is I'm going to simplify this, so I get 2400 times pi over 3, and that is giving my answer in terms of pi. But again, I'm going to type that into my calculator. Now if you are doing this on a calculator exam, you really don't need to be writing this. You can just go straight into typing this, just to save a bit of time. I definitely would write this down as form of your working out. So we'll just get the calculator up again. So again, we've got, again, just showing you exactly how to type it in. So I've got 1/3 times pi times 10 squared times 24, and it gives me 800 pi, which is exactly what 2400 divided by 3 is. I should really have simplified that, and then press SD, so it comes up as 251327. So 251327 2513, and I think it was 27. Let me just double check. Yep, 27 centimetre cubed, and there's your final answer. And then finally, for C, here we've got a square base pyramid. So again, I'm going to be using this. So again, V equals a third. Now the base of this is a rectangle, so it's going to be 12 times 6 times 15. So again, going through this, now I'm going to save a bit of time, just go straight into using my calculator, because I'm sure you get the gist of the other two previous examples. So here I've got a third. Typing it incorrectly, so we've got a third times 12 times 6 times 15, and we press equals, and we get 360. So that's quite a nice simple one, and that's going to be centimetre cubed, like so. And then moving on to two more obscure shapes. So here we've got a hemisphere. So again, looking at the volume of a sphere, well, that's going to be 4 over 3 pi r cubed. So the volume for this shape is going to be 4 over 3 pi r cubed over 2, or what I could use it as is 2/3, and it's going to be pi r cubed. So it doesn't matter which variation you're going to do, but the key thing to note is in this question we know that the diameter is 8.4, so therefore the radius is going to be 4.2, because remember, it's the radius is what information I need to take out from this to work out its volume. So V equals, again, I'm just going to use this formula here and divide it by 2. So here I've got 4 over 3 times pi times 4.2 cubed, and I'm going to divide that all by 2. Now when you divide by 2, I probably recommend that you do the top first. If you try and enter all of this in your calculator, it may look a bit confusing. It should give you the same answer as long as you've entered it correctly, but again, there's no harm in taking things slow. So here, let's load up the calculator. So we're going to do simple fraction. We've got 4/3 times pi times 4.2 cubed, and then we press equals, and then we divide that answer by 2, which gives us 155.17 it's going to be. So 155.17, and the units are centimetre cubed, and there is your final answer. And then finally for E in this particular question, so here we've got a triangular base pyramid. So again, V equals, and it's going to be a third times the base times the height. Now the base of this particular pyramid, what it's going to be, so the base is a triangle, so that's base times height divided by 2. Now although it may not look like this, but because it's a right angle triangle, the base of the height of the triangle is 6, and the base of that triangle is also 6, so then that's going to be 6 times 6 divided by 2, which gives me 18 centimetres squared. So in terms of my base, I'm just going to use the number 18. So here I've got V equals a third times 18 times the height, which is 15, and then if I type that into my calculator, which I'm going to save a bit of time and do this on the calculator that I've got in front of me, so times 18 times 15 gives me an answer of 90. So here I've got 90 centimetre cubed, and again, always remember to write down the units. Now typically in a GCSE exam, what you'd find is you might have a little box and the units may already be written for you, and if that's the case, you won't get a mark for writing the units. So definitely don't write, let's say this, so you're writing 90 centimetre cubed, because here you've got two sets of units. Whereas if a question just looks like a blank line or a horizontal line, then more likely you will get a mark just for writing down the units. So even if I wrote 900 centimetre cubed, there's a good chance I might get a mark just for writing the units, but again, that's a big if. So let's just get rid of that because that's not the right answer, and let's get rid of that as well. So moving on to question 2. So again here, these two questions will generally appear on a non-calculated paper, and so you might think to yourself, well, how can these be on a non-calculated paper? And the reason for this is what makes it more complex is working with pi. So for this, all we're going to have to do is leave our answer in terms of pi. Now we won't necessarily need it for the well, we will need it for the cone. That's, I think I thought it was a normal pyramid. So leaving in terms of pi, you'll then usually find it's either going to be a sphere or some form of cone. So for this, remember that our formula is 4/3 times pi times r cubed. So again, here we've got r equals 10. So v equals 4/3 times pi times 10 cubed. Now 10 cubed is 10 times 10 times 10, which is 1,000. So v equals, now if I do 4 times 1,000, I'm going to get 4,000. I've then got to divide that by 3, and then I've got a pi. And there is your answer in terms of pi. Then moving on to b, so again remembering that the formula for the area of a cone, so v equals, and it's 1/3 times the base times the height. And so here we've got that, so here substituting numbers in, we've got 1/3 times, now the base is a circle, which is pi r squared, so it's pi times r, which is 3 squared, times the height. And then if I simplify that, I've got 1/3 times 9 pi times 9. Now from here, what I can now do is multiply these three numbers together. So I do 9 times 9 times 1, which gives me 81, and then I have that over 3 pi. Then just check, can I simplify 81 over 3? Yes, I can. So that becomes 27 pi, and then don't forget the units, which is centimetre cubed. And there you go. So if you're not too sure on how to, in terms of simplifying your fractions, you could have got away with dividing 81 or leaving it as 81 over 3, but that does simplify to give you 27. And there you go. So moving on to question 3. So here we've got what we call reverse questions. So this is where we're given the volume and we need to work backwards to work out what part of the question is. Unfortunately, on question 3 we seem to be missing the x that we're trying to find, so let me just quickly put where the x is going to be, and the x is going to be there. Don't know why it's so thick. So let's just change that. So let's say x is one of the lengths of the rectangle. So for this, what we need to do is first of all establish what the formula is going to be. So v equals, and it's 1/3 times the base times the height. So here we've got, now the base is going to be 7 times x. So writing this all in, we've got v equals, well, the volume, let's first of all write down this first step. So here we've got 1/3 times, and then the base is going to be 7 times x times 20, and that all equals 560. So simplifying the left hand side, so I've got 1 times 7 times 20, which is 140, over 3, and then we've got x equals 560. So now what I need to do is solve this. I'm going to solve it for x. So the first thing I'm going to do is take the 3 over to the other side. So here I'm going to times 560 by 3. So here I've got 560 times 3, and again we're going to use my calculator for this. I've got 140, x equals 1680, and then I'm going to divide by 140, so x equals 1680 divided by 140, which gives me an answer of 12, and there is my final answer. Moving on to b again, so the formula for the volume of a sphere is 4/3 pi r cubed. So here I'm just going to substitute the numbers in. So here I've got 4/3 times pi times r cubed, and that's equal to 36 pi. Now when you've got things in terms of pi, what you can do is you can see that both sides have got a pi, so I can actually cancel those two things off from each other's, and then so what I'm left with is 4/3 r cubed equals 36. So the first thing I'm going to do is get rid of the 3. And how do we get rid of 3? We do that by multiplying by 3. So I've got 4r cubed equals 36 times 3. So 36 times 3 is 108. I'm then going to get rid of the 4. So I've got r cubed equals 108 divided by 4, which gives me 27. And then if I cube root 27, which is a cube number, and which I should know this off by heart, which gives me 3, and then just double check the units, so it's 3 centimeters. And again, I'm not going to write cube units because I'm not working out the volume, I'm working out a length, so that's why we're using single units. Now with question 4, here we've not been given, so this is where we now introduce capacity, and we're dealing to the nearest millimetre. Now for this, the key thing you need to remember is that 100 centimetre cubed is the same as 1 litre. Now when I'm working out the volume, and because I'm dealing my dimensions are in centimetres, then I'm going to end up with centimetre cubed. So what I'll have to do is then to convert that into millilitres, I would then have to use this sort of unit conversion. So here we've not been given a diagram, so if I wanted to, I could draw a diagram. So here is my water cup, which is in the shape of a cone, and it says that the diameter is 7 and the height is 12. And so what I need to do first is work out the volume in centimetre cubed of the cone. So here I'm going to do the volume is going to be 1/3 times the base times the height. And again, the reason why I'm constantly writing what the formula is, it's a good way of remembering the formula. You don't have to be writing down the formula in this, but as long as you're showing you're working out for this, so V equals 1/3 times the base, which is going to be pi, times, now for this, the diameter is 7, so that means R is going to be 3.5, so it's going to be times 3.5 squared times 12. Now if I type that all into my calculator, so I've got 1/3 times pi times 3.5 squared times 12, I get an answer of 49 pi, and which therefore equals, if I convert that into a decimal, gives me 153.93804 to decimal places. So the next thing I then need to do is then, step 2, not step 3, get ahead of myself there, is now convert into litres. So what I'm going to do now is, because 1,000 centimetre cubes is 1 litre, I'm going to do 153.93804 divided by 1,000, and if I divide that by 1,000, so it gives me 0. Again, all it's a case of doing is just moving the decimal point over a couple of places, so 153.93804. So in terms of millilitre, the nearest millilitre, that's going to be, my cut-off point is going to be here. So here we're looking at 0, well, it's going to be 0.154 litres, or it's going to be 154 millilitres, and there is our final answer. Now with question 5, the question is saying that a metal cylinder has been melted to make a metal sphere. Find the radius of the sphere. Now these types of questions are very, very popular, and obviously and generally worth quite a lot of marks. Now the first thing we want to do, that's probably not been mentioned on previous questions, is making sure that the length units are the same. So you always need to make sure that the length units are the same, and if they're not the same, then you would need to convert it so that they are, so either working with centimetres or metres or millimetres, etc. Try not to make, now the key is, a clue would be given in the question, So for example, if you can see at the bottom of your test paper it comes out like this, then you know that the units you're going to be using are going to be meters, so that's the one you tend to go for. Now what you want to try and do is make sure that you're using the correct units, because you don't want to be using either numbers too big or too small. You kind of want to pitch it just right, a bit like Goldilocks. So in terms of this, so the first thing we need to do is find the volume. So in terms of step 1, so let's get a pen. So step 1 is find the volume of the cylinder, because we need to know how much metal is being produced from this particular cylinder. So for this, what we need to do is the volume is going to be equal to, now for this it's going to be the base, because it's a prism, it's the cross-sectional area, which is a circle, so it's going to be pi r squared times the length. So substituting this in, I've got pi times the radius, which is 2.8 squared, and that's going to be multiplied by 9.3. So for this I'm going to simply type it into my calculator, which if I get here, so here I'm going to have, now it doesn't really matter what order you do it in, because as it's multiplying it doesn't really make a difference, but again I'm just going to just type it in exactly how I've done it, times 9.3 and press equals, and I get an answer of 229059, so 229. Now because this is not the final answer, I want to try and use the exact number where possible. So 0598, 0598, and the last couple of digits are 036. Now obviously you want to try and, you can save this as your answer feature as long as you're not typing anything else on your calculator. Now the step 2, what we then need to do is, using the volume of a sphere formula, find R. So now all of a sudden, from working out the volume of a cylinder, it now turns into a reverse question where I know that the volume is 229.0598036. I then need to type this in. So the volume of a cylinder is 4/3 pi r cubed, which hopefully we know now. So here I've got 4/3 pi times r cubed equals 229.0598036. So now what I need to do is get r by itself. So the first thing I'm going to do is get rid of the 3, and how do I do that? Is I times by 3, and then, now you might want to do this in different stages. So here I've got 229.0598036 times by 3, and I get an answer of 687.1794108. So that then equals 4 pi r cubed. So the next thing I then want to do, now you could divide by 4 and then divide by 5, or what you could do is be a bit smart and take this all over to the other side. So what's the opposite of timesing by 4 pi or dividing by 4 pi? And so what I'm left with is r cubed equals, and then I do 69, which should be still on my calculator, divided by 4 pi, gives me an answer of 54.684, and then 4 zeros, 1. And then the next thing that all I then need to do is cube root the answer, which, running out a bit of space, gives me an answer of, so if I press, and again let me just show you how to type this in on a calculator. So here we want shift and then r cube root, and then we're just entering the numbers in. So I've got 54.684000001 equals, so I've got a radius to 2 decimal places of 3.8, and so r equals 3.8 meters to 1 decimal place, and there is our final answer. Now moving on to question 6, this is what we call compound shapes. So this is where you've got numerous 3D shapes joined together to make one mega shape. So from this, what you want to do is spot which the two shapes are. So for this, with regards to A, here you can see I've got a cone, and for the second one I've got a hemisphere. And what you want to do is you want to work out each of those separate volumes and then add them together. So again, looking at a cone, that's 1/3 times the base times the height. And for a hemisphere, well, it's the volume of a full sphere, which is 4/3 pi r cubed, and that's all going to be divided by 2. Now in this we wanted to try and key out the key bits of information. So here I've got h equals 12, and again just double check to make sure your units are the same. Yes, with the both of yours, so we're working in millimeters this time, and the base is going to be pi times 4 squared, in other words 16 pi. So working out the cone, and again what I would strongly recommend that you do when you're doing this in an exam is actually work this out separately. So write down the cone and show clear evidence that you're working each of the bits separately. So generally speaking, in an exam this would probably be worth about 4 marks. You'd get 2 marks for correctly working out the cone, 2 marks for working out the hemisphere, and then your final mark would be from completely adding your answers together. And then you might even get a bonus mark, we should get a bonus mark for writing your answer to 1 decimal place as specified in the question. So in terms of the cone, that's going to be 1/3 times 16 pi times 12. And again, if I type that quickly into my calculator, so I've got 1/3 times 16 pi times 12, it gives me an answer of 64 pi. Now I'm going to leave that as in terms of pi, just because it's going to make it easier. I could work out the decimal version, which is 201.0619298, but again it's a lot easier, especially if I'm going to type this in again, just to write 64 pi, and also improves accuracy as well. Then for the hemisphere, it's going to be 4/3 times pi times 4 cubed, all divided by 2. And again, if I type that into my calculator, so I've got 4/3 times pi times 64, which is 4 cubed, I get 256/3 pi, divide that by 2, and I get an answer of 128/3 pi. So here you can see I've got my 2 components that I now need to add. Now again, if I was to write the decimal version of that, it would be 134.0412866. But again, because I've not finished my final answer, I've now got to combine these 2 things together. So here the total volume is going to be 64 pi plus 128/3 pi, and if I type that into my calculator, so plus those 2, I get an answer of, in terms of pi, 320/3 pi, or, which is asking me to do it into 1 decimal place, so it's going to be V equals 335.1 millimeter cubed, and there is my final answer. Then for question B, so again here what I've got is I've got a square base pyramid, and I've got a cuboid. So what I need to do is work out those 2 separate areas. So I'm just going to call this one #1 and this one #2. So working out the volume of #1, which is a square base pyramid, so that's going to be equal to 1/3 times the base, which is this area here, so that's going to be 3 times 3, and I'm going to multiply that by the height. Now in this I need to work out the height of the pyramid, so that's what this length here is going to be. Now from the diagram it tells me that the total height is 7, but the height of the cuboid is 2, so therefore looking at the difference between that and that, so the difference between 7 and 2 is 5, so the height of that pyramid is therefore going to be 5. Now if I type that into my calculator, so I've got 1/3 times 9 times 5 gives me an answer of 15. And then working out #2, so which colour pen was I using? It's #2. And then working out the volume of the cuboid, so that's going to be 3 times 3 times 2, which is 18. And so the next thing for me to then do is add the 2 things together, so the total volume is 15 plus 18, so V equals 33 centimetre cubed, and there is my final answer. So again, to be fair, the maths in this wasn't that difficult, so this question could easily appear on a non-calculator paper. Now, working with Frustums is a very high level. This is kind of like the creme de la creme of types of volumes and shapes that you could get asked to work out. Now, there's several ways in which you can work this out. You can either see a frustrum as either a cone, a full-size cone that's been chopped into two pieces, and the pieces that you want to focus on is the bottom half, or the same thing applies with a pyramid. So it's a big pyramid that's been cut horizontally, and it's the volume of the bottom half that you wanted to work out. Now, there are several techniques and ways you can work this out, and it all depends on what information is given to you in the question, and also how you approach the question as well. Some people may approach working out the volume of frustrum is, rather than remembering another set of formulas, is trying to think, well, okay, let's work out the full pyramid or the full cone, work out the bit that's been chopped off, take away the two answers, and you're left with the bottom base, and that's absolutely fine. It may require a little bit of extra work, and your life might be a little bit more difficult based on the information that's given to you. So for example, if you look at question 1, you can see the outline of the full size cone. So that would be fully acceptable for you to work out the top cone, work out the volume of the full cone, take the two answers away, and you'll be left with the bottom part, which is what you're wanting. Now if you look at question 2, that's going to be very difficult because you don't know what the actual the vertical height of the original pyramid is going to be. So that's where it's kind of flawed using that method. It isn't impossible for you to work that out, and again I'll show you when we move on to more extension questions on what we do to work that out. So what you may want to do is try and revise another set of formulas. Now the formulas were covered on the other presentation, on the other video I should say, and I've made a small version of this on the screen, which I know is going to be very difficult for you to see if you're working on a mobile phone or when you're working on a tablet. But again, what I will do is when I go through the next two examples, I will recall and I'll write down these formulas a little bit bigger so you can actually see them. So with regards to question 1, so again we're looking at a cone, so that's the first thing we want to do, and we've got a choice between using two possible formulas. Now in terms of a cone, we're looking at this. I can either use the formula of a third. So if I just write down the two formulas, so I can either use for this one, I've got V equals a third pi h times, and then it's going to be r squared plus capital R squared plus r. Now basically, if I just write down the values of this, r is the top radius, which is 3, capital R is the bottom radius, which is 6. Now h is basically the height of the frustrum. Now this hasn't been given to me, but I know that the total height of the full size cone before it was chopped was 16, and the top half was 8, so therefore the height of this frustrum here is going to be 8. Now it's not taking this height, it's basically doing 16 take away 8, which gives me the same exact height. Or what I could do is I could use this bottom formula of V equals, now in terms of when do we use each of the formulas, now I would use the bottom formula, or let's just write it out. So h over 3 equals, and it's the top area plus the bottom area plus the square root of the top area times the bottom area. Now I would tend to use this formula if you have regular shapes as the base and the top half of the frustrum. So for example, it would be near impossible for you to, I wouldn't recommend using this formula or the top formulas when you have got, let's say, a cuboid as the base. So in question 2 you can see we've got a square base frustrum, so for that you could use either formula. For if it was a cuboid or a rectangle, then I would definitely recommend you use the bottom one, because obviously then it might be slightly skewed in terms you'll get two different answers, which is not what you're wanting. So let's have a look at going through these questions. So for first of all, now I'm going to use the top formulas to work this out. I'll show you how we still get the same answer working through either or. So to start off with, I'm going to use this formula here. So with #1 and substitute numbers in, I've got a third times pi times 8 times r, which is 3 squared, plus 6 squared, plus, and it's going to be 18, like so. And if I type that into my calculator, which I'm now going to do, if I just reach for it, so I've got a third, and just entering it correctly, a third times pi times 8 times, and then bracket 9 plus 36 plus 18 gives me an answer of 168 pi. And if I press the SD button, because the question is asking me to give it to one decimal place, I get an answer of 527.8, and it's in centimetre cubed. Now if I was to use the second formula, so I'm just going to call that #2, then what that would be is 8 over 3, so that's h over 3, times, and the top area, well, that's going to be 9 pi, plus the bottom area, which is going to be 36 pi, plus the square root of the top area, which is 9 pi, times 36 pi. And if I type that into my calculator, which I'm now going to do just to make sure if this comes up with a different answer, I may have to edit this video quite heavily. So here we get 9 pi plus 36 pi plus the square root of 36 pi times 9 pi, and then just making sure that I've got correct sort of number of brackets, etc., and I get the exact same answer of 168 pi, which leads into 527.8 centimetre cubed to one decimal place. So you can see it doesn't really matter which formula you use, particularly for a cone or a conical frustrum as it's sometimes called. It's entirely up to you. Now moving on to question 2, again we can use either formula, so I can either use v equals a third h, and then it's going to be b squared plus a squared plus ab, and you can see how the two formulas are linked. The only difference between a pyramid frustrum and a conical frustrum is the fact we've got a pi in what's outside. So substituting the values into this formula, I'm going to get v equals a third times 6 times, and then again, it doesn't really matter which one I do first, a squared or b squared, doesn't really matter, but let's stick with this. So we've got 21 squared plus 14 squared plus 14 times 21, close bracket, and again, the more complexity of this is actually typing it into your calculator and making sure you don't get a math error or syntax error, I should say. So I've got a third times 6 times, and then 21 squared plus 14 squared plus 14 times 21, and I get an answer of 1862 centimetre cubed. Now again, if I was to use the other formula, so v equals h over 3, and I've got the top area plus the bottom area plus the square root of the top area times the bottom area, I should get the exact same answer. So let's just type that in just for argument's sake. So I've got 6 over 3, and then here the top area is going to be 14 squared, or 14 times 14. The bottom area is going to be 21 times 21 plus, and then the square root of 14 times 14 plus, times 21 times 21, and close bracket, and typing that all into your calculator, and again I get the exact same answer. So it doesn't really matter which formula you prefer, because you should get the same answer regardless. Now the next thing we move on to are the extension questions. Now these you tend to find are going to be more circled around level 8 and level 9. So this is where you're combining several topics together to answer a more complex problem. Now the main difference between, you can see this, and the previous questions that we've tried is, in this particular question we're missing the height of the frustrum. Now in this we're looking at a conical frustrum, so in terms of this, the first thing we need to do is, well, we can't use the formula without working out the height of this frustrum. So the first thing we need to do, and now with this what we need to spot is the fact that the two cones that we've got, so either the top cone and the full cone, are similar shapes. Now it might be difficult to see this, but what we need to do first is, if we see this as now if I just draw some lines here, so here I've got two similar triangles. I've got this big triangle here, which I'm just going to highlight in blue, and I've got a smaller triangle which I'll highlight in orange. Now, in terms of the information I've been given on the question, is I know that this height is 2, this is 5, and the total height is 10. Now, if you're not too sure on similar shapes, then I strongly recommend you watch the video, and there is one on the channel based around this topic. So I'm going to kind of assume that you've watched this so you know what I'm talking about, but if you don't, I strongly recommend you watch that video, particularly Similarity 2 I think it's called, and hopefully it should give you some clarity in terms of what we're doing here. So the first thing we need to do is find the scale factor of the two cones, or in this case the two triangles. So the scale factor is going to be 5 over 2, which is 2.5. Now that basically means that the height of this cone here is going to be where I need to use the scale factor to work out what that cone is. So that in terms of the length, the height of the smaller cone is going to be 10 divided by 2.5, which therefore is going to give me 4 centimeters. So that means that the height of that top cone is going to be 4, and if the total height was 10, then that means that the height of the frustrum is therefore going to be 6. So from this I know now that h equals 6. Now once I've got h equals 6, it's now just a case of picking which formula to choose. So either I can use this formula here, or I can use this formula here. Now I'm going to go for number 1 first. So let's just use this formula here. So here we've got, for number 1, we've got v equals 1/3 times pi times h. Then we've got r squared multiplied by r squared plus r. Now here, if we state the values, then I can just replace r and r with a's and b's. So here we've got the top radius, so r is going to be equal to 2, and capital R is going to be equal to 5. So then substituting those numbers in, let me just write that again. So here we've got v equals 1/3 times pi times h, which is 6, and that's going to be multiplied by 2 squared plus 5 squared plus 2 times 5, which is 10. Then it's just a case of simplifying. Now I'm going to assume that this question could be non-calculator, so let's do this without a calculator. So 1/3 times 6 is 6 over 3, which is 2. So that's 2 pi, that's outside. 2 squared is 4, 5 squared is 25, plus 10 gives me 39. So then v equals 2 times 39, which is 78 pi centimetre cubed. So that's leaving my answer in terms of pi, or I could work it out as a decimal, which gives me an answer of 245.0 centimetre cubed, and that's been rounded to 1 decimal place. Now alternately, as I mentioned, we could have used the other formula. So now let's use this one. So here my top area is the top base, which is a circle. So that's going to be pi r squared, so that's going to be 4 pi. The base area is going to be 25 pi, and again we know that h is 6. So then substituting numbers into that formula, we get 6 over 3. The top area, which is 4 pi, plus the base area, which is 25 pi, plus the square root of 4 pi multiplied by 25 pi. Now if I just deal with this first, let me just highlight this bit here, and then we just close that bracket as well. So then from this we can then, if I just simplify this, 4 times 25 is 100, pi times pi is pi squared. So we're doing the square root of 100 pi squared, which then just gives me 10 pi. So what we're left with is 6 divided by 3, which is 2. I've got 4 pi plus 25 pi plus 10 pi, which simplifies to give me 78 pi centimetre cubed, or I can write it as a decimal as 245.0 centimetre cubed, and that's to 1 decimal place. As you can see, either of those formulas would be absolutely fine because it gives me the same answer. Extension question. So again, this kind of applies to the same thing. So here we've got a pyramid and we've got the top pyramid height here. So again, I don't know what the length of the top base is going to be, and that's something that I then need to work out. So again, if I draw my two triangles like so, this is what I'm trying to work out. Now I know this is 15. Now from this I know that the total height of the pyramid is going to be 12 plus 6, which is 18, and I know that this top half here is 12. So working out the scale factor, it's going to be 18 divided by 12, which simplifies to give me divided by 6, 3 over 2. So to work out what x is, so x equals, and it's going to be 15 divided by 3 over 2, and if I type that into my calculator, it gives me 10. So x equals 10 centimeters. So I can write 10 there. So from this I can then use the formula to work this out. So here I've got h equals 6, a equals 10, b equals 15, and again, so volume equals a third times h, which is 6, times 10 squared plus 15 squared plus 150, which is basically 10 times 15, close bracket, and if I type that all into my calculator, so I get a third times 6 times bracket 100 plus 15 squared, which is 225, plus 150, close bracket, I get 950. And again, don't forget the units of centimetre cubed. And then now for this particular question, it would have been easier to have used the boxed formula, simply because we can work out the top area, we can work out the bottom area, and we also know the height of the frustrum as well. So this would have been easier, but obviously it's a more complicated formula to use, or one that you could remember that's not going to be given. So here we can see that the top area, now that we worked out 10, is going to be 100. The base area is going to be 225, which is 15 squared, and we know that h equals 6. So then substituting all of this information into this formula, we get 6 over 3 multiplied by 100 plus 225 plus the square root of 100 times 225. And if I plug that all into my calculator, I get an answer of 2 times 475, which gives me the same answer as I got in the previous solution of 950.